All right, thanks for joining everybody. Today's webinar, of course, we're going to be talking about the role of network security in an AI-ready enterprise. I have an amazing presenter for you today, Jay Thontakudi, who's one of our product marketing managers, and all-around czar of all things security. Great guy, you're in good hands. I'm your host, Scott Manning. I'm just here to basically make sure everything runs smoothly, help answer Q&A, that kind of stuff. We also have a couple guys on the Q&A panel. Derek Tay and Satya Damanur, who are both part of our technology product management team, also in good hands. And so you're in good hands today. So please ask lots of questions is the point. And with that, a couple housekeeping items before we get started. First is always a disclaimer that if we talk about anything that's future or coming or roadmap items, that's always subject to change. So things can change. Roadmaps can change, timelines can change. So don't hold us to anything that we say because you never know what can happen. And then last but not least, housekeeping. So as I said before, we have a couple folks attending or managing the Q&A panel. So please ask questions. We love questions, but please use the Q&A section for those questions. If you use the chat, often they can get lost in the shuffle of things. But if you use the Q&A, we make sure we can get them answered. Also, anything we don't get answered, if we have open questions that we haven't answered by the end of the webinar, we'll actually probably be turning them into a blog and answering a lot of those questions in like a blog format. So please feel free to ask as many questions as you can. We'll answer all of them that we can, but please use the Q&A feature. And of course, this webinar is recorded, so watch your emails for that webinar recording in the coming days. And with that, I will pass it over to Jay.
Thank you, Scott, and hello, everyone. Thank you for joining us. Good morning, good afternoon, good evening. To get started, looking at AI adoption in the enterprise, a couple of interesting statistics put out by McKinsey is something of interest. About 72% of the organizations that McKinsey surveyed indicated that they have adopted AI in at least one of their business functions, typically in marketing, in sales operations, human resource, in their IT, new employee onboarding, and so on. What we also find is that 65% of those applications tend to be Gen AI apps. Now, of course, the most common one that everyone is familiar with is ChatGPT, but there are others that include the likes of Microsoft Copilot, Grammarly, and so on. But what we also found interesting in a different survey from one of the companies that is part of the Forbes Technology Council is that 50% of the organizations feel they are less prepared for AI-associated cybersecurity risks. Now, like anything else, right, when you introduce a new class of applications, when you onboard a new set of users or endpoints, your attack surface continues to expand. So let's look at what are the factors that influence or affect security when it comes to AI applications. The first one we call out is obviously the human errors. And I won't put any statistics on human errors here. I'm sure many of you have dealt with breach related to human errors before. But an interesting example that you see in the public domain is that of Samsung engineers who actually put out some proprietary code as a part of their query to ChatGPT. And in doing so, they actually ended up sending some sensitive information that became a part of ChatGPT's data set or ChatGPT's context. Now, if a threat actor tricks the ChatGPT application and extracts out this sensitive information, it ends up compromising Samsung's intellectual property. And interestingly enough, Samsung came to know that their employees are using ChatGPT after this happened. So they put acceptable use policies in place to prevent any of their employees from using ChatGPT in future. Of course, that is a very stringent application of policy, so to speak. But what comes to focus, which has been the case that IT teams have been struggling with even in the past, is that users themselves cannot distinguish between the enterprise perimeter and the public domain, or the enterprise domain and the public domain. So you end up putting some privacy data out in the open that can be leveraged by threat actors. Now, Second factor that also comes into play when it comes to AI-associated security risks is the fact that not all models are created equal. The models, in terms of their architecture, their performance, and security, they continue to vary. The model itself cannot distinguish between good data and bad data, or between good intent and bad intent. And threat actors are looking to take advantage of this notion of obliviousness. Now, of course, AI model developers are putting in a lot of effort to try and secure their models and the data they use as a part of their data set. But that is a effort that is continuing to improve or evolve. But for an IT team, they have to keep this in mind when they are thinking about the security risks. Now, the threat actors themselves are not sitting quiet. In a different survey, again, these are all data points because the use of AI applications is continuing to emerge as we see, and a lot of different consulting firms who are providing a trusted advisory role are putting out some interesting data points. So this one is from Deloitte, where organizations indicate that they see a 46% increased exposure to threat leveraging AI. And from a threat actor perspective, they are looking to see how they can use AI to improve their tactics and techniques to launch their exploits. And one of the areas they are putting an active focus, that is, the threat actors are, is to use AI-assisted threat campaigns, where they want to speed up their ability to scan for vulnerabilities so they can get access to an entry point in an enterprise. And once they do so, they want to use attack automation to launch and speed up their exploits with the ultimate goal of getting to that sensitive data that is of interest to them. And last but not the least, threat actors are also using GenAI chatbots to actually evolve the malware code so they can evade the protection offered by security tools that are pretty much up to date with the known virus signatures. So they want to beat some of these defenses that are already in place. Now, what we also notice is a prediction that Gartner made. This was way back in March of 2024, last year, where they indicated that more than 50% of the data that is used by enterprise will be created and consumed outside the data center or cloud. Now, this prediction was done when, way before the groundswell of all these AI applications that have shown up in the enterprise infrastructure. And what happens with AI applications is that it further strengthens that prediction Gartner has made. And the reason for that is AI architecture and the AI traffic is distributed in nature. Now, if you think about ChatGPT as an application, right, it's very simple to understand that a lot of users sitting in branch or campus locations or in some remote sites access ChatGPT application that is sitting in a SaaS cloud. So it is a very straightforward north-south or south-to-north traffic pattern, which is very typical of a lot of other applications we have seen. But there is a whole slew of agentic AI applications that many of the enterprises are putting a lot of their development efforts in, where you have a bunch of agents that are integrated into the SaaS application or enterprise application itself. And these agents are installed in different branch locations. And these agents have the ability to make autonomous decisions where they can execute a set of workflows based on certain conditions that could come up. One of the examples one can imagine is if you take a retail chain where the retail enterprise installs an inventory application which integrates agentic AI. And at each store, they have this inventory application running where this application is monitoring all the different products or SKUs that are available on the shelves. And once a specific product falls below a threshold in the inventory, it can automatically send a notification to the distribution facility to include this product in question as a part of their next shipment. At the same time, this application could be communicating with agents in other stores nearby, so it gets an understanding of what the inventory levels look like for different products. So when the store manager wants to get an idea, what type of products are low on inventory or high on inventory. They can also get a comparison of what's happening in other stores without having to look for that information going back to a parent server or a parent application. And in this case, what also happens is the agentic AI application does not require a whole lot of human intervention or does not require a whole lot of guidance from the parent model, which could be the LLMs that are sitting in the data center or cloud. The fact here is that the traffic patterns that we see with AI is going to evolve further than what we have seen in the past. So peer-to-peer communication, branch-to-branch communication are among the things that are going to become more prevalent as we see more applications come into the market. So from an AI experience perspective, right, there are two aspects that bubble up very quickly. One is the accuracy of results that you get in using AI applications. And the second one is timeliness and response. In the area where we have accuracy of results, the model developers themselves are putting in a lot of effort. I mean, you must have heard terminologies used like model bias, model hallucinations. There are talks about something related to retrieval augmented generation and so on. There's a lot of different techniques that the model developers are developing while they're also improving the security posture they adopt in developing these models. But one area where the accuracy of results can be compromised is when a threat actor is able to poison the data that is used for training or poison the data that is sent as a part of a query to trick the model to revealing some information. So security can become a big factor when you think about accuracy of results. The second one happens to be timeliness in response. I mean, if I'm using a Grammarly application, let's say, to put together a big legal document, and I need help from Grammarly when it comes to the accuracy of my document, if I don't get a near real-time experience in terms of guidance, I might as well shut off Grammarly and go do Google search to find certain context and certain ways in which I want to frame my sentences. So timeliness in response comes into play. But underneath both these requirements, what you see is network security and network performance coming up as two key dependencies or requirements that can enhance the AI experience when you have enterprises onboarding applications. And to look at how these requirements actually translate when we think about network performance and security, is that the traffic pattern, as I mentioned, in terms of peer-to-peer communication, that's going to change. But also there is going to be a better alignment between upstream and downstream bandwidth. What I mean by that is if we think about traditional applications, users or end devices sitting in branch, campus, or remote locations, when they want to access an application and get some services, they send a request and the application send their response back. The size of payload in the request and that of the response tend to be different. So your upstream and downstream bandwidth requirements tend to be somewhat different. So if you look at broadband providers, they typically talk about what your downstream bandwidth looks like. And that tends to be an order of magnitude higher than the upstream bandwidth. But with AI applications, there is a lot more information that gets included as a part of the query itself so that you get a customized response. So the payload differential tends to be a little bit smaller, or the upstream and downstream bandwidth requirements are going to continue to evolve as we move forward. Now, this bandwidth symmetry requirement does not have any direct dependency on security, but it is mentioned here for completeness, if anything. But latency sensitivity is important. It just takes the requirement to the next level because a lot of AI applications tend to operate in this near real-time request response mode. And then peer-to-peer communication, as I mentioned, is also going to become more prevalent with branch-to-branch communication becoming a requirement. Now, when you think about security and the ability to apply the necessary security levers to safeguard this AI experience, the security enforcement has to happen on an optimal path. between the model consumers, which happen to be users and applications or workloads that are running at the edge, and the models themselves that are deployed in the data center or in the cloud. So instead of your traffic, application traffic, going to where your security solutions are, which in a lot of cases happen to be at the data center, it is important for the security to follow the AI traffic, especially when it comes to getting a better AI experience. And of course, the crown jewel of any enterprise, which happens to be sensitive data, you want to make sure that you are protecting that data. But simply by the virtue of onboarding AI applications, you don't want the compliance requirements that are in place to be violated. So data security and compliance are pretty important in delivering a safe and a secure AI experience. And because there is a lot of action that is happening outside the data center, what we are calling out is that network performance and network security are pretty tightly integrated as an immutable requirement when it comes to AI experience. They are pretty much like two sides of the same coin. And so the question that comes up is, how do we address the security requirements for AI adoption? For all the other applications in the past, we have used a layered defense when it comes to any new applications, any change in the work culture that has come up, especially post-pandemic, any new applications that get onboarded. The same approach actually applies with some additional context when it comes to AI applications. And we are going to focus more on the network security aspects that you apply outside the data center. The first one among them is obviously the need to use some kind of policy-based access approach. So you're not exposing the entire enterprise to all the different AI applications that are out there. You use a policy-based approach to determine who needs access to what applications. And once they gain access, what are the type of actions they can or cannot undertake with those applications. So there are some techniques or technologies or capabilities that are mentioned here, and we are going to go into more details in the forthcoming slides. But a policy-based approach to restrict access, gain visibility on what is going on is important. And then, of course, applying the solution to offer threat prevention. And this can be not just for known viruses or known threats that are out there, but it also includes the need to protect against evolving threats, to protect against zero-day attacks. So, anti-malware capabilities, sandboxing functions, the ability to use high-risk isolation, for example, to basically have the ability to protect users when you don't have clarity on exactly what a particular application is doing or what kind of a purpose it serves. IDS, IPS, among other things, which are traditional defense mechanisms in place. Obviously, the most important piece of all this exercise is to prevent any sensitive data from leaving the enterprise perimeter. I mean, talked about Samsung as an example use case. So data protection using data loss prevention capabilities do come into play. Now, of course, there are a lot of solutions that bring a specific capability to the table, but using purpose-built security solutions that serve a single function or a couple of functions can be challenging. It leads to tools and service proliferation. It leads to policy proliferation. And policy creepage becomes a big problem in the process. So having a mechanism to actually offer a centralized policy management for threat and data protection becomes important. But in terms of enforcing that policy, you need the flexibility to determine the optimal path on which you are able to apply that security. This applies not just to AI applications, but we have also seen this come about for other non-AI applications too. And of course, we mentioned about the fact that with AI applications, the traffic patterns are going to be truly distributed. So you want to be able to protect all the different traffic patterns that are out there. So if you have your traffic today for any branch-to-branch access going through some kind of a cloud enforcement or a data center enforcement, you may want to take a harder look at those traffic patterns and determine if there is a way for you to enforce security on the optimal path between branch-to-branch communication patterns that you will observe. And with our solution, which is VeloCloud SASE secured by Symantec, we actually bring this layered defense to the table. And what we do with VeloCloud SASE, many of you may be familiar with, but just for completeness of understanding, right? With VeloCloud SASE, we provide a secure and reliable access for users and workloads at the edge or in branch and campus locations to applications and workloads that are in the data center or in the cloud. And we do that using three modular components which are part of our solution. One is the VeloCloud SD-WAN solution, which provides reliable path-optimized connectivity for traffic that is originating from the different branch locations and then going to different destinations in the cloud or in the data center. And we also have integrated security capabilities on our SD-WAN devices. So now you can provide branch security without compromising network performance using a single device, which happens to be on our SD-WAN edge devices. Now, apart from VeloCloud SD-WAN capabilities, we also have VeloCloud SD Access, which is our remote access solution that enables remote users who are operating or working outside the branch or campus locations to have access to their applications and services. But we not only provide the necessary security using zero trust network access, but we also provide a path optimized connectivity for these remote users. Again, the focus is to ensure that we are providing security, keeping path optimization in mind. And the third component of our solution, where we have taken significant strides in integrating our VeloCloud solution with, is the Symantec Security Service Edge or Symantec SSE solution. The Symantec SSE solution brings a collection of comprehensive capabilities that are deployed on our SASE points of presence. These are cloud-hosted locations from where we are delivering all these services, which is actually a global network of points of presence across different parts of the world. And the whole objective when it comes to security is to provide a proactive threat and data protection. And the objective is to protect traffic on all ports, protocols, and patterns, and also simplify the ownership of our solution when you adopt VeloCloud SASE. Now, VeloCloud SASE is built using what we call as a VeloCloud or VeloRAIN architecture. VeloRAIN is an architecture we announced back in November during VMware Explore in Barcelona. And VeloRAIN stands for VeloCloud Robust AI Networking Architecture. At a high level, the objective of this architecture is to provide the end customers or users with an uncompromising network performance and network security using AI and ML capabilities within the product, and also to extend the capabilities of AI to reduce the operational burden or improve the operational efficiency when you adopt VeloCloud SASE. Now, we'll go into some of the details on a bunch of capabilities that I mentioned about. The fact that we have to take traffic patterns into account, we have to consider a layered defense, and we also have to consider the different use cases or environment in which typically a lot of enterprises operate. So going into the specifics, right? The first thing you need is obviously visibility into all the applications that are in use. What you see here is just an example snapshot of GenAI usage across all the different branches in an enterprise. So getting an understanding of what applications are in use gives you an idea about what type of traffic patterns you could be looking at. An interesting data point to observe is that we have seen in the last year or so of monitoring applications on our deployed SD-WAN edges. About 60% of our deployed SD-WAN edges carry some form of AI application traffic or the other. And it is not just about getting visibility into these applications. What you also need is the ability to determine which applications users can and cannot use. So with our ability to use URL filtering integrated with our Symantec SSE solution, we have categorized all the Gen AI applications that we have seen out there. We have the ability to detect about 172 different Gen AI applications. But it is not just that. What our threat researchers have done is, for each application, they have assigned a risk rating from risk level 0 all the way to risk level 10. And typically, what we have seen enterprises do is anytime when they see a risk level of 7 or higher, they have pretty much blocked those applications from being used. And this approach is not just confined to AI applications. The Symantec threat researchers have analyzed over 46 billion URLs that are out there to determine the purpose they serve, the risk they bring to the table, the kind of reputation they carry before they assign a certain risk level to those applications. And these are all pre-packaged and available to use when you adopt our solution. And all you have to do is put a policy in place to determine what your allow and block action is going to look like. So restricting access to the applications is one of the first steps that you take when users are accessing AI applications. But what you also need to account for, obviously, is the use case for remote users. Now, post-pandemic, there has been a lot of discussion about a hybrid workplace and remote users want to have access to applications. Those requirements also apply with AI. But what happens with AI is, especially when enterprises look at developing their own AI applications, you have your own in-house AI domain expert. And because this is an evolving area, there is not a whole lot of domain experts or AI developers that are out there in the market. So chances are you may not have all your AI developers in one location. There could be many of them who are operating out of a remote site. And you want to make sure that these AI developers are the only ones who have access to the AI workloads that are being trained, that are being tested, and in the process of being brought into a production environment, for example, whether it is in the data center or in the cloud. Now, using our VeloCloud SASE or VeloCloud SD access component that I mentioned about earlier, we use zero trust network access capabilities to provide access to these remote users only to those applications they are authorized to use. So when these users want to get connectivity, we perform a series of checks, and this connectivity is set up on a direct path between these users or application workloads that could be running at the remote location and the public cloud location or the data center. But what our solution does with the help of our VeloCloud orchestrator is it's constantly looking at what the performance of this connectivity looks like. And what we have done is hosted a bunch of relays in the cloud, which we call as VeloCloud SD Access relays. And we check to see if the performance through our relays would be better than the so-called direct connectivity that is established between the user and these applications. So again, the notion of path optimization, while we check for a comprehensive set of ZTNA capabilities, comes into picture. So among the things we check for, apart from the credential checks with multi-factor authentication, we also check to see, based on policy that is configured, the location from which users can access these AI workloads, the type of device they are using to access these workloads. Is it an enterprise managed device, or is it a device that is unmanaged? And then you can have a policy to say block the user from getting access. And if you go through the list, right, do they have the right certificates? Do they have the antivirus checks that are much needed from an endpoint protection perspective? So zero trust network access applied on the user's connectivity in a path optimized fashion, so you don't compromise network performance when you're dealing with network security, is a key aspect of the solutions we bring to the table. And this is something that is worth keeping your thoughts on when you think about onboarding AI. Now, one more area that many of the enterprises deal with is having consultants, contractors, technology partners work out of different campus or branch locations on certain projects that they are onboarded for a specific period of time. Now, these contractors or consultants, they bring in their own laptops to do their work, and it is unclear what kind of security rigor is applied to those end devices. So there is always a possibility that they may carry some kind of a malicious content that they may not be aware of. It may not be intentional, but they may be completely unaware of that malicious content. And if that traffic is getting mixed up with your corporate traffic or AI traffic, it can lead a threat actor to go through lateral movements, privilege escalation, and finally get to data exfiltration. So one of the fundamental defense mechanisms that you can apply at these branch locations is to protect your AI and corporate traffic from exposure to the guest traffic or the guest segment using network segmentation. And by doing so, you can isolate the traffic that is compromised from your other corporate or AI traffic and prevent any lateral movement, and subsequently preempting any attempts towards privilege escalation or eventual data exfiltration. Now, there is also an element of security defense that you can apply where you have enhanced firewall services on our SD-WAN edge devices that can also help when you are dealing with certain traffic patterns when it comes to guest user traffic. But anytime the guest user wants to access enterprise applications, their traffic would have to go through a firewall. So you are safeguarding your infrastructure till that traffic hits your firewall environment. So that is another area where you can restrict access, apart from the applications that users can get to, who can get access to what applications, and also preventing third party from impacting the application usage. I talked about visibility early on, saying that you need to have an understanding of what's going on in your environment. So maintaining visibility and exercising control becomes very important. Again, going back to the case of the Samsung engineers, right? It was shadow AI activity, similar to shadow IT, right? Where employees in the organization are using applications outside the purview of IT teams. With our solution, using what we call as CASB or Cloud Access Security Control, we have the ability to get access to all the applications. But not only that, you can actually control what activity or what set of activities users can or cannot undertake based on their roles and responsibilities. So our Cloud Access Security Broker used in conjunction with data loss prevention capabilities can actually prevent the earlier use case of Samsung engineers, but it can prevent any kind of sensitive data from even making it out of the enterprise domain. And should any such activity be undertaken, you can configure a policy to block that activity, and you send a notification to the SOC team about this violation that was attempted by one of the users. So maintaining visibility and control using a combination of CASB and DLP not only helps prevent sensitive data from leaving the perimeter, but it also helps you continue to stay in compliance with the requirements that you already have in place, whether it is PCI, GDPR, or HIPAA requirements. Yeah, what I'm going through in the next couple of slides, and I have to apologize for for the screen looking so small here when it comes to the text that is here. This is a dashboard capture of an example of ChatGPT where the enterprise decides that their employees can access ChatGPT, but they want to make sure that while they are giving access to all their users to ChatGPT, they want to prevent certain activities from being undertaken. For example, they want to prevent any PCI type information from being shared with ChatGPT. So there is a policy in place to prevent PCI data as a part of the data loss prevention profile, to prevent PCI data from being onboarded as a part of a query while interacting with ChatGPT. And should any such activity be undertaken, you have a policy to block that activity and also log a high-level severity notification and send it to the SOC team. So when a user, for example, attempts to place a PCI sensitive data, in this case happens to be credit card information, and pass it as a part of the query to ChatGPT, ChatGPT gives a response back to the user saying that something has gone wrong, in generating a response. But what has happened in the back end is the solution has blocked these credit card numbers from being sent as a part of the query. So ChatGPT is unable to understand what this query is about. So it is confused and it is giving the standard message it gives sometimes. But what happens in the back end is obviously the action is blocked because you have configured a policy to do so. But a notification is sent, an alert is sent to the SOC team, and it is called out as a high alert. The user's information, I have blocked it out over here, but the user information is shared with the auditors and the SOC investigators, and details about the timestamp, which application was in use, what policy was in violation is all called out. So we want to make sure that you get the relevant information so that SOC is not burdened with additional notifications in the process. Again, this is a simple example of having visibility into the GenAI apps, having policies put in place as to what should the usage be, what activities can be undertaken, and in case there are violations, making sure that you're safeguarding not only the enterprise, but also the user from putting out sensitive information out in the public domain. Now, there are a few other aspects that I just want to touch on. One of them happens to be the ability to provide isolation for certain conditions that may be completely outside your control. One of those examples is the fact that on a daily basis, right, there are about 250,000 websites that are created. A lot of these websites are created by their owners. They register their domain, they create a website, and in many cases, they go completely dormant. It could be for 6 months, 12 months, 18 months. So it's very difficult for IT teams or even the security solution providers to know exactly what's going on in this website because you don't know their purpose, you don't know, what's going on with that domain. And so in many cases, it's impossible to gauge, are these legitimate sites or are they not? But what is definitely possible is that an employee comes across such a website and finds that they have a solution that looks very attractive and they can use. And of course, they are promoting it to be a free software without understanding that they are clicking on something on that website, which is sending a malicious payload. Now, with high-risk isolation, we have the ability to create an air gap that prevents any malicious script or malicious code from these websites that are uncategorized or that are already classified as high risk by our researchers from actually making their way to the end device. So we are able to isolate many of these activities, whether it is zero-day attacks, evolving threats, or even known threats from making a landfall into these end devices. So preventing these threats from reaching the endpoints actually further tightens your security posture from any activity from even making its way into the enterprise, getting to the endpoint, and then with the threat actors trying to speed up their ability to, make the lateral moves and get to the, the sensitive data that everybody is worried about. I did talk about path optimized enforcement earlier and how important that is. With our solution with VeloCloud, we offer you the flexibility to enforce security at the branch location. I mentioned earlier that we have integrated security, which is enhanced firewall service capabilities on our VeloCloud SD-WAN edge devices. So you can activate security at each of our SD-WAN edges. So now you get path optimized or you get an uncompromising network experience with our VeloCloud SD-WAN solution, but at the same time, your branch users and AI workloads at the branch are all protected. And among the traffic patterns we can protect against is branch-to-branch traffic, public cloud to branch, data center to branch traffic, and also to a certain extent SaaS traffic. But we also have our Symantec SSE solution and a number of those capabilities I just highlighted just now, where we can provide a cloud enforcement capability So you are able to enforce security on that optimal path between the model consumers who are sitting in the branch and the models that are located in different cloud destinations. So having the ability to protect both Gen AI and non-AI applications on an optimal path is very important. And having the ability to protect traffic on all patterns uh, and being able to do so with our solution gives you that flexibility. What you see here is just a quick dashboard with anonymized data from an actual deployment of our enhanced firewall services integrated with the SD-WAN solution. We leverage capabilities like IDS, IPS, URL filtering, and so on to highlight any vulnerabilities that are out there. I mentioned earlier that threat actors are accelerating their ability to scan for vulnerabilities. We can actually prioritize and indicate which vulnerabilities you need to pay attention to so that you can close the gaps and prevent any entry from the threat actors. And to do all these things, we leverage AI and ML internally. For example, our global intelligence network is a very comprehensive threat intelligence gathering capability, which gathers organic threat signals from over 157 countries. We analyze over 1 billion threat signals on a daily basis from common entry points in an enterprise, which happens to be endpoints, email, and the internet. And we use AI and ML to actually analyze this data, curate it, and if we find any threat evolution that is of interest and of importance, we flag it to the Symantec threat researchers, who are then able to further determine what the results of this analysis would look like. And those results are then automatically integrated into our Symantec SSE solution. So if we see that a Gen AI application that was initially evaluated to be of a lower risk rating, but over time, while observing the activities, the traffic, and the behavior, we determine that it actually poses a higher risk. We can automatically shift that risk rating from a low to moderate risk rating to a high risk rating of, let's say, 7, 8, or 9. Once that risk rating is adjusted, your policies are already in place saying that any application that is risky above a risk level of 5 should be blocked. So you get automatically protected. And our objective, obviously, is to prevent, is not just to prevent any of this threat, but also it's not just to detect, I'm sorry, it's not just to detect any of these threats, but also to prevent them from reaching your enterprise. There is another aspect of AI that I want to call out, which we are calling as VeloBrain. This is an AI assistant for VeloCloud. And the idea here is to be able to offer AI-assisted configuration help when you are using our solution, AI-assisted operations help when you are using our solution, and also if there are any parts of our solution that you need to learn about to understand, we provide AI-assisted learning. Now, this VeloBrain capability is in tech preview right now. It is shipping with our latest release called release 6.3. So if anyone in the audience is interested in kicking the tires, understanding how we are able to improve your operational efficiency using VeloBrain, please feel free to reach out to us. We would be very interested in getting your feedback and further enhancing our capabilities. So in closing, what we have gone through is basically giving you an understanding of the AI landscape and the threat landscape we are dealing with, the defense mechanisms and security postures that you can adopt. Our solution actually provides a very robust threat protection capabilities with the flexibility of providing enforcement both at the branch and in the cloud. So you're able to protect against all the different traffic patterns. Our data loss prevention capabilities are deployed by some of the major financial customers. So what you are getting is a solution that is tested in operations in a compliance and risk-prone environment. And last but not the least, we are leveraging AI to provide advanced threat intelligence so you can adopt a proactive threat posture in this exercise. Now, among the things that you can do to further understand what our solution is about, and in fact, we have a lot of assets that we have put out on our websites. The first one here is, VeloCloud SASE itself, understanding all the capabilities and how it can help meet your AI needs. The second one we have is a video that talks about our enhanced firewall capabilities integrated natively into our SD-WAN solution, a comprehensive set of Symantec SSE capabilities that are shipping with VeloCloud, where we have undertaken a lot of effort to bring about a seamless integration between our VeloCloud SD-WAN and VeloCloud SD-Access components with the Symantec SSE solution. Also, we have put out a comprehensive report with the help of third-party Tolly to highlight all the different capabilities that are out there. Among the things that I mentioned today and even more, you can read this report to get an idea. And of course, last but not the least, we have a blog that specifically calls out how you can have a secure adoption of Gen AI applications using our security capabilities. So that actually brings me pretty much to the end of this presentation. If there are any unanswered questions that we can take, I know we are pretty much coming up on time, but if there is anything that we can answer live, definitely we are happy to do so.
Yeah, a couple questions came in. Jay, one just barely popped in. Which firewall brands are compatible with VeloCloud SD-WAN?
So we have our own solution that is integrated with with VeloCloud SD-WAN, and we are leveraging the NSX firewall capabilities, which are embedded or integrated into our solution. When we talk about compatibility with other firewall solutions, obviously our VeloCloud SD-WAN solution can direct traffic to wherever your firewall solution is, which typically tends to be in the data center. So we can definitely send the traffic to whatever firewall vendor you're using in your data center. We are completely agnostic to those.
Perfect. Another one was, how do they get access to VeloRAIN?
Yeah, so I would say reach out to your account teams, and they will definitely put you in touch with our engineers, our technical product managers, who will be excited to help you get going with this. So reach out to us. We'll help you gain access to release 6.3, so you can kick the tires with VeloRAIN.
Perfect. Another one asked about slides available afterwards, specifically the ones with the YouTube links. I believe that is something we absolutely can do, right?
Sure. Yeah, absolutely. Everything is in the public domain. Whatever is in preview, as we mentioned. But otherwise, we are definitely happy to share all the content.
Yes. All right. So with the recording link, we'll see if we can get the slides sent out with you. But if anybody needs them prior to getting the recording link, just feel free to shoot myself an email, and I can throw my email in the chat just so everyone has it. I'm sure you get it if you need anything. All right. Those are the unanswered questions. I'll give a quick ask to Derek or Satya. Do you guys have anything that you wanted to bring up or clear up or chat through real quick before we finish the webinar up?
No, I just wanted to expand on a little bit on the firewall question that came up in terms of what Jay answered. Like Jay mentioned, there's the firewalling capability is actually built into our SD-WAN. So it is a secure SD-WAN solution that we have, which now is expanding in the context of AI by leveraging the VeloRAIN framework. So there's going to be a lot more that VeloRAIN as an infrastructure is providing for enhancing the security aspect of it, right from including, recognizing the Gen AI applications to using AI-based modeling to come up with what traffic patterns are going to look like and predicting the behavior of the networking. So security is going to be an integral part of that framework, where once we detect that, how do we perform security on it? So I think please take a look at the resources provided. You will see why it makes more sense to look at the VeloCloud solutions from a Gen AI perspective as well.
Thank you, Satya.
Perfect. Derek, anything to add?
No, I think Jay covered everything. I would echo Satya's comment to take a look at the resources that Jay shared on the slide towards the end. They really dig deep into what we offer in terms of Gen AI and security capabilities.
Perfect. I think Derek, we may have had a question that just popped in for, it looks like you, asking about VeloCloud access. I think he's SD access. Does the remote user connect to a closest POP using FQDN?
So for SD access today, we do not connect to a POP. We actually connect to what we call client connectors, and yeah, that's using FQDN.
Perfect. And I guess, and even in the VeloCloud side, how does it know which POP to connect to? The SD access, and let's just go VeloCloud in case that was the actual question.
So with you mean as in SD-WAN?
Yeah. So in SD-WAN, how does it know which closest POP to connect to? Does that use FQDN? I'm assuming the answer is no, but I just wanted to.
No. So with SD-WAN, typically the edges use geolocation to kind of like connect themselves to the closest gateways, and then from there, basically they get access to out to the internet or through to Symantec SASE, depending on whether they set up a business policy.
Okay. Thank you. Oh, and another question coming in. They're coming in just perfect timing. Is there a use case for leveraging VeloCloud SASE on top of VMware DFW ATP? Is this the sole solution for protection from AI threats that Broadcom offers?
I would consider it complementary in the sense that VeloCloud SASE acts outside the data center. So if anything at all, you definitely need, as I mentioned earlier, there's a lot of action happening outside the data center. So our solution helps you both with the security and the performance aspects. Satya, anything you want to expand on?
No, perfect. Yeah. I think it's just a question of what we are targeting as the segment here that like Jay highlighted, right, about the distributed nature of the agentic AI applications which are running on these edges, right? For example, the retail example that he highlighted. So we are talking about security enforcement at those distributed branches or that kind of a setup versus where you think about the distributed firewall, it is purely in the context of a data center where you have multiple applications running and workloads running, and you want to enforce ATP on that workloads. So, which is slightly different from what the use case that we've highlighted here. Both are equally relevant and useful in their own segments, and both have their own AI usage and relevance in terms of how they addressed the challenges presented. It's just the segments are two different segments here that we're talking about.
Perfect. All right, Derek, another question. It sounds like clarification on the initial one. Do you want to just give us a little high-level overview of how that client connector works with the SD access? Meaning, like, where do you put them? Are they physical boxes? How are they deployed? Just like a 30-second overview of how that client connector works.
Sure. So the client connectors are typically set up as virtual machines. So this can be set up by the customer in any environment that they have. And then more recently, we've introduced on Tech Preview the client connector that's running on an edge. So you are able to also terminate the SD access connections onto an edge as well.
Perfect. Hopefully that clears up the question. All right. With that, I don't believe we have any more questions coming through. You have my email address as well, everybody in the chat. So if you do have a follow-up question, please feel free to email myself, and I'll make sure I get it to Jay or Derek Satya or somebody who can help answer that. But watch for the recording. We'll try to get the slides out with that recording as well. But if for some reason you're not seeing that email, again, feel free to email myself, and I'll make sure you get the slides. With that, thank you, Jay. Awesome presentation. And thank you, Derek and Satya. And we'll go ahead and close the webinar for today. Thanks, everyone, for joining.
Thank you.